Good morning, everyone, and welcome to the H-Prize Technical Data Collection Requirements webinar. My name is Chris Worth, and I am the organizer for this meeting. We'll begin shortly, but first I have a few housekeeping items to tell you about. Today's webinar is being recorded, and the recording, along with the slides, will be posted to the H-Prize website in about 10 days. We will send out an email to attendees once those are posted to the site. All attendees will be on mute throughout the webinar, so please submit your questions via the question box that you should see on your webinar panel. Please keep questions specific to technical data collection requirements. All other questions related to H-Prize should be submitted to hprize@ee.doe.gov. We will cover those questions during the Q&A at the end of the presentation. Since we have multiple speakers today, please indicate who your question is for when submitting your question. With that, I would like to introduce our DOE host, Katie Randolph, joining us from the Golden Field office in Golden, Colorado. Katie is a technology manager in the Fuel Cells Technologies office. Good morning, Katie.
Good morning, Chris. Thank you for the introduction, and thank you all for calling in to listen to this webinar on the data collection requirements for the H2 Refuel H-Prize. As Chris mentioned, I'm a technology manager, and I sit in Golden. I'm actually sitting here with Chris Ainscoe, who's a senior engineer from NREL. NREL has been developing the data collection system and requirements, so he will be going into the details of that part of the webinar. I also have on the line with me Sarah Studer. She sits at headquarters, and she's a fellow with the FCTO office, and she's been an integral part of developing and managing the H2 Refuel Prize, and she'll help field questions and answer questions at the end of this session. So you, Chris and Sarah, you can say hello.
Hello, everybody.
Hello. So just to kick this off, I'm going to give a brief overview of the H2 Refuel Prize, and then, as I mentioned, I'll turn it over to Chris to go into the details of the technical data collection system and requirements. So this is a 2-year competition that opened in October of 2014, and it came at a perfect time as automakers are beginning to announce the release of their fuel cell vehicles to market. One of the major one of the barriers that remains is infrastructure, and the H2 Refuel H-Prize is intended to incentivize the development of these small-scale systems for non-commercial refueling to help supplement the large-scale infrastructure development. So as the Fuel Cell Technology Office is challenging America's innovators to develop on-site systems to generate and dispense hydrogen to fuel vehicles at homes, community centers, and small businesses, and the best entry will win $1 million. So we're in the first year, and this is the time for teams to begin to develop and form and put together their preliminary designs. You must register to be a competitor by October 22nd of 2015, and then your designs will be due by October 29th of this year. And at that time, we'll have independent judges review these designs, and we'll announce the finalists in December of 2015. We'll then have about 7 months to prepare systems, get them installed, and then we hope to begin data collection in the June to July timeframe of next summer. We'll also, while the systems are up and running, have an open house so the public can come and see the systems of the finalists in action. And then the competition closes October 31st of 2016. We'll then analyze the technical and cost data and determine the $1 million prize winner. So again, the goal is to deploy these on-site hydrogen generation systems that use electricity or natural gas and can be used in homes, community centers, retail sites, or similar locations to fuel hydrogen vehicles. As I mentioned, we're in the first year now, and as you begin to form teams and put together your designs over the summer, what will be required for the determination of the finalists at October 29th will be the designs, blueprints, plans for installation, and preliminary data to demonstrate that you can meet the minimum criteria. We'll then have an independent group of judges who will select the finalists. It will be, of those that meet the minimum criteria, the best shows out of those. We'll announce who those are in December. Again, you'll have 7 months to build and install, and then we'll begin the remote testing and data collection. And so this is just more information on that. So if you see here, once we have the finalists and the data collection, about a year from October, we will analyze the data, and again, the entries must meet the basic criteria and will be scored based on the financial and technical criteria. Because some of the criteria are considered more critical, there is a weighting of the different criteria, and that you can see that table on this slide here. The cost criteria is also shown. We will not be focusing it on this webinar and hope to have a future webinar to discuss the cost criteria, but it will be evaluated by an independent auditing firm. And the team is required to submit things like the bill of materials for installation and system operating costs. We're also going to provide more details on what is needed to evaluate the cost criteria once the finalists are chosen. The bottom criteria, which consists of the dispensing pressure, dispensing time, standard fills per day, and testing availability. And you can see that for some of these criteria, you have different criteria for the home and community systems. And Chris is going to discuss what data will be needed to evaluate these criteria and how it will be collected. So here is the website. Hopefully most of you have already gone and visited the website, but it has a lot of information. You can get the rules and guidelines as well as the data specifications on this page, see the timelines and other interesting news posts there. I didn't mention this at the beginning, but I would also like to acknowledge the Hydrogen Education Foundation. They administer the prize and they run this website. Next slide. Also, on this slide, you can go and learn how to join a team. So it says if you're interested in joining a team, you can fill out the form on the right side here. And we do want to note, though, that neither HEF or DOE endorses any member of the list or provides guarantees about their suitability. This is just an opportunity to facilitate potential contestants to find other teaming partners. I'd also like to mention that we will have a poster, or HEF will have a poster at the AMR this year on Tuesday night of the AMR, and it'll also be a good time to meet other people interested in the prize. So you go to the next slide. So now I will turn it over to Chris, and he will get into the meat of this webinar. So Chris, it's yours.
Thank you, Katie. So as she mentioned, I'm Chris Ainscoe. I'm a senior engineer at the National Renewable Energy Lab, which will be responsible for collecting and analyzing the data that will be provided to the judging panel in order to score the finalist projects. So those judging criteria are on the hprize.org website. You can see hyperlinks here on how to compete, the rules and guidelines, and on the requirements. I do want to note here that should there be any omissions on anything that I say or anything that I say conflicts with what the official requirements and data guidelines are, those documents on the website are the governing documents, so you'll refer to those in case of any conflict. The first thing we need to look at are the minimum and maximum criteria. Again, these are split up somewhat by whether the system is a home system or a community system. And primarily the split there is on the fill time and the number of dispensing events per day. So 1 kilogram in the home case and 5 kilograms in the community case. Of note here, I think, are the requirement to meet the J2719 fuel quality standard, and we'll have more on how you're going to meet that requirement later. And also being able to meet relevant vehicle codes for the vehicles that you're fueling. So for instance, if the system targets light-duty vehicles, you need to refer to SAE's J2601, which was recently released. And you also need to meet relevant safety codes and standards, AHJ approvals, those things for your location. There are 6 broad scoring criteria. We're going to talk about 4 of them today. The remaining 2 are cost ones, and those will be covered in a future webinar. So we're not going to talk about the total installed cost or direct cost today. But we will be talking about dispensing pressure, time, number of standard fills, and the system availability. The way the criteria are split up, and you may remember this from Katie's slide, is that the higher you score in any given category with your system design, the more points you get. So a 350 bar or higher system will score 1 point, and a 700 bar or system higher will score 5 points. Similarly with dispensing time, the faster the system can dispense, the more points are available. So in order to get the minimum score of 1, you have to be able to do 10 hours per kilogram for a home system or 60 minutes per kilogram for a community system. Number of standard fills per day, and a standard fill again is 1 kilogram. You need to be able to do between 1 and 5 or more for a home system and 50 or more, 5 to 50 for a community system. The availability of the system, which I'll define in a minute, needs to be 80% or higher for regardless of the system. And I realize that this is a challenging metric compared to the state of hydrogen stations out there today, but this is one of the things this prize is meant to push, is to push the availability that we can get out of a station. It needs to be higher. So this is going to be a tough one to meet, and I'm sure you can all do it. How we calculate availability, it's calculated on a weekly basis, so 168 hours available in a week. We'll subtract off any repair time measured in hours, and we're defining repair time as the time between when a repair or maintenance intervention is initiated and when the system is returned to operational status. So even if there isn't technically a repair with somebody going out with wrenches, but you have to manually go and reset something, that's going to count as repair time. Delay time is going to be the time, it's logistical delay. It's between when a failure happens or the system is no longer filling or generating hydrogen and a repair is initiated. And this may be reporting, time to learn about the failure, time to get parts, time to get people on site. All of those logistical delay kinds of things will count against availability as well. And that's all that goes into the numerator. The denominator then is just the total number of hours in the week. In addition, finalists will be required to collect detailed maintenance logs that will tell us information about the types of failures, safety reports, other data on the system, so we can make a detailed assessment of system availability. The scoring criteria, the 6 criteria are not weighted evenly. So you can see there's a score multiplier here, dispensing pressure being the highest, availability and installation cost being number 2, and then the balance of dispensing time, fills per day, and cost per kilogram each have a multiplier of 1. Additionally, bonus points are available in 3 categories. If the system can provide at least 35 kilograms of hot water, or 25,000 BTUs per hour of space heating, or 10 kilowatt hours of electricity in a day, 1 bonus point is available for each of those. So those are not required, but again, bonus points are available. These are some scoring examples. The top example, and these are also in the official guidelines, so you don't need to go over them in detail here, but the top example is for a system that scores the minimum. And what we're doing here is essentially taking the scores in each category and doing the dot product with the score multiplier and coming up with the total score. So the minimum score is 10. Example B, you can see a system that reached a 475 bar pressure, so scored higher in that category, and dispensing time, et cetera, availability resulted in a higher score. So that is how these systems will be scored by a panel of independent judges using the data that we will collect. So on to that data. Why do we collect it? As I've sort of alluded to, we need to collect the data because there's $1 million at stake, and this is a very high visibility, high profile project. We want to make sure that all the systems are being measured accurately and independently, and so that we can provide objective information to the judging panel. It's critical. How we will collect data. All finalists will be required to have a data collection system that NREL will provide installed in their system, and we will come out to install it. I'll talk more about that in a minute. Data will primarily be collected through a Modbus TCP IP interface. So if you don't know what that is, get a controls engineer and find out. The finalists will be required to have, what this means is you'll have to have a PLC, programmable logic controller, or similar controller for your system that can be configured as a Modbus server. And the DCS that NREL will provide will be configured as a Modbus client, and we'll ask the server about every 30 seconds for any system data. It's important to note that we're not requiring an additional PLC. So whatever main PLC that you have to control your system, that's adequate. As long as it can speak Modbus over the TCP/IP protocol, that will be fine. So you don't need an additional PLC just for data collection. We will collect data for a minimum of 60 days, about 2 months worth. It doesn't need to be 60 continuous days, but we want to have enough time to assess availability and performance of the system while it's actually being used. So it can't be 60 days of it just sitting there. It has to be running and operating and doing vehicle fills. And you can see more information on that in the guidelines. So to collect data, we have two broad types of sensors that we'll use. So first of all, to note, the sensor package must be included at the expense of the contestant, because there can be a wide variety of systems out there. We don't know what people are going to come up with. We don't want to get into the business of telling you what sensors to put and how to install them in the system. Just know that you'll have to install certain sensors that can measure certain things, and you have to provide us the outputs from those. Those two types of sensors are isolated ones, and those are isolated sensors are ones that connect, the signal connects electronically only to the DCS. So physically, the physical parameter it's measuring, say pressure or a valve position, will connect to your system, but the electronic signal coming out of it will only connect to DCS. Non-isolated systems, sensors, those will be able to connect electronically to your controller, your PLC, which will then relay the data over Modbus to the DCS. And the reason we do that is to reduce the cost burden and allow you to have some of the sensors do double duty, both for data collection and also for your control. An example you can see here, in the top in blue, you can see temperature transmitters and pressure transmitters, etc., reporting to the contestant's PLC, which will then relay the data on Modbus to the DCS. And then you'll have some isolated sensors as well. This, for instance, is a valve position open and a pressure transmitter relaying to DCS. And I'll get at the very end into a table of what the requirements are for these sensors. So facility requirements for the DCS, we need it to be in a safe location, protected from the weather, vandalism, things like this. It should be behind a fence so it's not going to get broken or stolen. We need 120 volt power, regular 15 amp circuit. Well, the DCS should only consume about 50 watts. We will need access to either an RJ45 connection to get to the internet so the data can come back to NREL, or failing that, the internet relay is our preferred option, but failing that, the systems will come with a cell modem, and as long as we can grab a GSM cell network with sufficient strength, that should be okay to grab data as well. So we need one of those too. So traceability. We will require all of the finalists to supply NIST traceable certificates of calibration for all sensors that the DCS relies upon. Further, the sensors need to be within their OEM's, the manufacturer's calibration window during the data collection period. If the sensors are not in calibration when we're collecting data, that data won't count toward the 60 days. So site visits. As I mentioned, NREL personnel will come out at NREL/DOE's expense to install and verify the operation of the DCS and the candidate system through at least one test fill. This is important, so we need to have the system fully operational and ready to go, not doing shakedown or commissioning still when we come out. So we won't schedule visits based on anticipated dates when you say that you think you'll be ready. You need to have the system actually running first. And those installations need to be completed by the end of July 2016. Earlier is okay and will help make our lives easier, but know that that won't get you any advantage in the scoring. It just makes it easier for getting all the systems instrumented and the data flowing back here. So we encourage you to schedule that as soon as practicable. So one more note on site visits. If NREL's personnel come out and the system is not actually operational or can't be verified and we can't hook up the DCS for whatever reason, the candidate may, at their expense, have us come out on a second visit, or they may withdraw from the competition. So those are the options. It's very important to have the DCS installed and functioning appropriately. So for purity, as I mentioned, there's a purity requirement, which will be measured relative to the J2719 standard. And there is a sample collection standard based on ASTM D7606, both of which are referenced below. You'll need to have these samples done, contract with a lab, again, at the contestant's expense, to have a chemistry lab come out and handle the samples and retain custody of the samples. The samples can never be in the custody of the contestant, and they need to go back to the lab with the lab's personnel. The lab then must mail a notarized copy of the results directly to NREL. This is a lot like when places ask for your college transcript, right? You have to send them directly to wherever they're going. So they have to come directly to us. The address is down there, and that should be fairly straightforward. A word on data ownership. So the DCS itself, the hardware will remain the property of the Department of Energy, and at the end of the data logging period, has to be disconnected by the finalist and shipped back to NREL at the contestant's expense. Data collected by the DCS will remain the property of DOE as well, and we will store that in the National Fuel Cell Technology Evaluation Center, which is an off-network secure data center located at NREL, and the data will be handled with our then current security procedures, which if you want more information on those, you feel free to ask me after this webinar. Contestants will receive a copy of the results that are provided to the judges for their systems. Those results will not be made public unless we mutually agree to do that later after the competition. Final scoring results, however, will be made public. So a word on data integrity. It's very important because, again, there's $1 million at stake and a high visibility project that no one takes any steps to adulterate or falsify, conceal, or do any kind of fraudulent activity related to signals that come to the DCS or any of the sensors. And it's important to note that if somebody does that, that may constitute a false statement under federal law, which can carry a penalty of up to 5 years in prison. And I think we're all very interested in making sure no one goes to prison. So don't cheat, okay? Onto the data requirements. So just these next two slides are a high-level overview of what the data requirements are, and these, again, you can download off the website and see them in more detail. So these are the required signals that we need to verify the required criteria. And then on the next page are the optional criteria. So I'm going to zoom in here and go through a couple examples very briefly. So this first two lines show an example of an isolated and a non-isolated signal. So the first one, time, we need the contestant's PLC to report to us time based on a 24-hour clock measured in UTC in epoch time every second, in precision in seconds. We'll only poll you every 30 seconds, but we need the precision to be in each second. So when you see here the signal type listed as Modbus TCP/IP, that means that's a non-isolated signal and will come to us via your PLC. I also give you some Modbus data types. This particular one requires 2 holding registers because it's a 32-bit integer, and holding registers in Modbus are only 16 bits long, so we need 2 of them. Then you see the dispensing pressure, so we'll need the pressure at the dispenser as it goes into the vehicle, located as close to the nozzle as possible. That will come to us as a 4 to 20 milliamp signal. That's an isolated signal, so that cannot hook up, any of the signal wiring cannot hook up to your system at all. It needs to come directly to the DCS. And that's so we can verify the information that comes out of your PLC. Further down the list, we see dispensing time, and we're going to measure that with a binary on-off, which is just a set of dry contacts that will be on the main on-off valve of your dispenser. So that's just going to be a binary value that will be reported, again, to us directly. That's an isolated signal. And then we'll have hydrogen dispensed. So you can't see the footnotes here, the double asterisks, but on the requirements document, you're required to measure one, but not both of these, because we can calculate one from the other. So you need to give us at least one of these. The accuracy requirement for these is pretty broad, just because of the state of sensor technology today. It doesn't allow easily for a high accuracy measurement. So we've broadened that category up to make sure people can meet it. That is a non-isolated signal that will come to us over Modbus. And I have some suggested scalings here that will allow the data to come across as an integer, but then we can still retain some floating point precision. And then preferred Modbus addresses here. These are subject to negotiation. If your PLC needs these addresses for whatever reason, we can move them around, but if to the extent you can make them the same, that makes everybody's lives easier. With that, we'll go to questions. As Chris Worth mentioned, please type your questions into the Q&A dialog on your webinar, and we will take it from there. So our questions will be fielded by Sarah Studer, who is at headquarters in DC.
Hello, Chris. Thank you very much. Yep, I am looking at the questions that have been submitted, and also we have some questions that, based on things that we've gotten earlier, we expect to be questions. So if you have any questions, don't try raising your hand or talking. Please send them into that. So one of the first questions we got was whether J2601 covers this in their fueling protocols.
Covers, I'm not sure. Hi, Nico. Thanks for the question. I'm not sure what you mean by this. So J2601 does cover light-duty fueling of vehicles, and I know they're working on drafts for material handling, for instance, and other things like that. But I think you may type in a little bit more specificity about what your question is.
And as a follow-up, I wasn't sure if you had a more technical answer to this. J2601 is relevant for the vehicles for which it's relevant, if that makes sense. So it is, the requirement is that they're compliant with relevant codes. So for example, these can fuel vehicles that aren't automobiles, light-duty vehicles such as forklifts. So it would be whatever the most relevant codes for those are.
Right, that's a good point, Sarah. So as you can see, the title, the official title for J2601 is Fueling Protocols for Light-Duty Surface Vehicles. So it's really meant for passenger cars, what you think of them as passenger cars and light trucks.
And we have some clarification, which is specifically thinking about these, the home systems and the slow fueling plus the small amount of fuel dispensed.
Oh, okay.
And specifically the tables.
Yeah, I'm not sure that the tables in J2601 cover that very long, drawn-out type of refueling as well. Basically, I think that's slow enough that it wouldn't be on the J2601 tables. The only point by saying is that it needs to be with relevant fueling protocols, but it needs to be relevant, as Sarah said, to the vehicles that it's relevant for, so that you can, you'll be able to fuel them.
Right. And as an answer to a question that we got, whether there would be a place to ask questions later, just so you know, if you miss something, you forget to ask it, or there's a question you have that doesn't relate to this testing. Yes, so not only can you put it in here, but I'll end with 3 ways that you can send us questions later to be asked.
Yeah, so I'll put that back up at the very end, but don't submit questions there now.
Please don't. I won't see them. Okay, so a next question we have is we have a couple questions about the bonus points.
Okay.
So one is about how hot water is defined and, I guess, or measured. So if you can explain that for the hot water bonus.
So we'll measure hot water with a thermocouple, or a temperature sensor, of course, and a flow meter. As to what temperature we're defining hot water as, we'll apply a reasonable standard for what potable hot water entails, which so the question is how hot the water is. Is that right?
It says, do we define hot water?
Yeah, so it's 35 gallons of water per day. I think the question of what is hot may be up to some interpretation, but we can use a reasonable standard for what potable hot water is. So not 400 degrees Celsius.
Right, the idea, yeah. The next question was about the heating, and this may be, it's a question that may be a little technical, is that 25,000 BTUs, is that comparable to the heat output of a barbecue?
I am not an expert in barbecues.
Neither do I.
I don't know.
And I would have to look that up, but it's based on the way space heating is measured. BTUs is used for a lot of things, but one of the things is space heating measured.
Yeah, and that's BTUs per hour, just to clarify.
Okay, next question on bonus points. Are there any bonus points for the inclusion of inline hydrogen quality sensors? So
that is not a criterion in the competition right now. So no.
Right, and so just for one more step, the scoring criteria that was listed in those tables are the only scoring criteria. So there's no hidden bonus points. Okay. The next question is, there a current standard of how much power you use to pump and deliver regular gas?
Right, like gasoline?
I guess so, yes. Sorry, I was just reading this. So I believe that that's what the question is. If that's not, yes.
I don't, so I'm looking at the question. Is there a standard for how much power you use? I'm not aware of a standard, if there is one. And even if there were a standard, it wouldn't really be applicable because, as you know, gasoline is a liquid. However, hydrogen, as used in light-duty vehicles, is a gas. It's a high-pressure gas. So the power required to pump and compress those things is very different. So it's really not an apples-to-apples comparison.
Right, and regardless, it doesn't sound, and you can answer this better, it wouldn't affect the scoring, the technical data collection, would it?
No, it would not.
Okay. So some additional questions. So just generically, what are the steps for this DCS?
So the DCS is currently being designed, but the prototype that we have for it is the size of your home microwave, maybe a little bit bigger. Some of that will depend on the finalist's installation, and we'll of course talk to the finalists when we get to that point about where we're going to put it. If we do need to put the DCS in a Class 1 Div 2 zone, it will have to be in a Class 1 Div 2 Group B enclosure, which is larger. So we'll work out those issues, but it's not very large.
Okay. What are there specific physical connections that they need to build into the system to connect to the DCS?
Yeah. So as I mentioned, the sensors all need to be supplied at the contestant's expense. And what we will expect when we show up with, and NREL's people show up with the DCS, is we will expect there to be pigtail leads run all the way through conduit to the location where the DCS will be placed. And we'll mount the DCS and then terminate on the system. Now, if it's, for instance, a 4 to 20 milliamp signal, that'll need to be a twisted shielded pair, maybe 18 gauge wire. For the TCP/IP Modbus, that will be an RJ45 wire. We'll need Cat5, Cat6 cable for that. Again, running through conduit is preferred to keep it protected, and if it's going to be in the classified environment, it will have to be run through conduit and sealed off. But we would prefer, actually, we really need to install the DCS and make sure it operates before you pour the concrete into the seal-offs. Because once that's done, you can't pull any more wires, of course.
Great. So another question we got in is, to be clear, we do not have to accomplish actual vehicle fills, but it is possible to simulate fills in a non-fueling station certified location.
There is a provision in the requirements for simulated fills, correct, Sarah?
There is. Yeah, I think there's possibly a few questions in here. The other issue is the non-fueling station certified location. The system does have to meet all of the safety requirements for the location that it is installed in.
Right. I think what this question is getting at is, if they're in, and if the questioner feel free to correct us if we're wrong. But I think what he's asking is, if they're in a location where they aren't currently allowed to drive up vehicles and fuel them, if they can do simulated fills. And by simulated fills, we mean a fill into an actual tank, just not a vehicle. And if that's okay, and yes, that is okay. But to Sarah's point, it still has to meet all the safety requirements for whatever the facility is in.
Okay, and feel free to follow up with questions. Okay, that sounds like we did answer the question.
Okay.
Okay, another question. If there's a sensor in the non-isolated set that you've identified, but they wouldn't want to use it for their PLC for whatever reason, would they be able to directly connect those to the DCS?
So, I'm sorry, what was the question again? For non-isolated systems, non-isolated sensors?
Right. If there's one that they don't want to route through their PLC.
Oh yeah, of course. Yeah. So if there's a sensor you want to put in and route it directly to the DCS, if you don't need it for anything, so let me go back up to that slide. And what we're talking about here is, so if instead of, say, this sensor here, this pressure transmitter, you didn't need this for control or monitoring of your system and you wanted to route it directly to the DCS, that is fine. Just note that this arrow is one way. So the DCS will not report data. So if you need extra control or data on your own, you can get to the DCS will not report back to your PLC.
Okay. And then another question, where do we get the NIST calibration certificates for the sensors?
Yeah, so NIST, and you can see, where's our NIST slide? So NIST maintains a website. I'll just bring it up here. I don't want to do your survey, thank you. So this shows all the NIST calibration services that they run. And the way traceability, it has a bunch of national standards for different things, mass, pressure, other things like that, which should load, but it isn't. What happens is sensor manufacturers will then take their company's reference standards to NIST, and will calibrate their reference standard, and then they'll keep their reference standard and use it to. Here we go. Yeah, pictures worth 1,000 words. So. NIST will keep the standard. The company's reference standard will then be used to keep calibrated a company working standard that this will be on the manufacturing line, and that will be used to calibrate the individual devices that will be installed in. That's what we mean by traceability. This may sound like a bit onerous, but really manufacture this and offer this as a service. You just need to specify it when you order the sensor. You need a calibration certificate. And again, as I mentioned, the sensors need to be within their calibration window during the data collection period, and we will be checking that when we're on site. So we have all your calibration documents ready to go, so we'll check those when we're on site. And as I also mentioned, when we're on site, we require to do at least what we can witness and gather data on. So we want to be able to see all the data for an entire test fill. We want to witness it with our own eyes so that we know what a test fill looks like when we see it in the data when we're not there. That's the point behind that. Okay, any other questions?
Okay, thank you. Right now we don't have any more questions on the technical data collection, and I want to remind everybody that we're focusing on those questions. So if you have questions on general topics, please submit them, and we'll show that screen again. This slide. The slide of places you can submit those questions to. There will be later I'll cover those also. But if you submit them through the other ways, we may be able to answer them more quickly. So we did have one.
I wanted to note one thing, Sarah. So actually, I stated in the link here to the heavy-duty vehicle standard right here for J2601. We'll correct the slides before they're posted, but the one we're going for, the one I wanted to reference there, is the light-duty standard. Although, if you're making a community system for heavy-duty vehicles, this one would apply. So.
Thank you. That explains one comment we got that I couldn't figure out what it meant. We did get one final question as I was wrapping up, and that is, when you mentioned about needing to witness a test fill, does that mean they need to have a vehicle there for the test fill?
Either a vehicle or the vehicle simulator. So if you're going to do a simulated fill into a tank that's not in a vehicle, that needs to be there. So.
Great. And
very good question.
Good. A last question: is a 0 score in any category is disqualified? And according to the guidelines, the systems do in fact need to get a score of 1 in all categories to qualify.
Right. So, yeah. So if you, as Sarah mentioned, if you get a 0 in any one of these categories across here, then you're disqualified. And the reason for that are that are that range in order we need that we see the bar high systems are people are having to innovate and come up with new ways to meet these challenges in order to score them. All right.
Okay, and with that, unless there are any last-minute questions coming in, get a few more, but those are the last of the questions.
All right, I'm going to put up the site or the information for if you have questions after this webinar. There are ways you can submit them. One is to email h5ee.ue.f, and we actively monitor that email address. And so questions to that, Sarah, will be posted on the website for answer to questions?
So in general, when we get commonly asked questions, we'll anonymize them and on the HPRIZE website, which is the next bullet. So if it's a one-off question that's likely to only be relevant to one person, we won't put it up on the FAQs. And if you send it to us and you put in details about your company, we're going to anonymize that just to make it a more general question.
Right, and I think if test and your controls engineers weren't on this call, you might want to go over this material with them, and if you have questions at that point, submitting those to hprize@ee.ue.f might be a good way to get those answered. And then do you want to talk about Twitter, Sarah?
Sure. So there is a Twitter. The HEF runs the @H2Refuel Twitter account. And back here.
All right, and if you have general questions on HPRIZE, there will be a webinar in the future where we'll have more of a general discussion.
It takes about 10 days to get everything up. We post on the hydrogenandfuelcells.energy.gov website. I expect that you will also be able to access it through the hydrogenprize.org through links. So if you want to share this with with anybody else, it'll be available.
All right. Thank you, Sarah, and thank you, Katie and Chris.